Hello, Matthew Mathers. Today we're continuing with scientific notation, but we're adding or subtracting. So what you hope for is the way the sheet starts, which is for the powers of 10 to be the same. So here I have 5 adding 3, and they have the same powers of 10. When that happens, you keep the power of 10 the same, and you just add the numbers in the normal sense, and you get an 8. If I wanted to switch that to be a subtract problem, the only real difference is we'd subtract to get a 2, as long as the powers of 10 are the same. This one will go a smidge harder. On this, the powers of 10 are the same, so we'd start off by copying the power of 10. 8 plus 4 is going to be a little bit of a pain, because that's going to make a 12. 12 is bad news because the rule on scientific notation from yesterday is that this number had to be between 1 and 10, and adding can sometimes take you to be a little too big, and we're going to have to modify this answer. If this had been a subtract, we'd have 4 here and we'd be fine, but adding will sometimes need to be modified. To modify this, we don't want 12, we need to relocate the decimal to make it 1.2. As yesterday, we need one number to the left of the decimal. This had 2 to the left of the decimal, and that's not allowed. So we'll have to modify this, and we'll have to make payment for that. In math, you can't just change stuff unless you can somehow bring balance to it. So if this is getting smaller, we need to take the power and go bigger. So this went down to 1.2, so the power goes up 1, 6 up to 7. Then it'll venture into some problems where the powers of 10 aren't the same, and you're going to have to do that kind of a change around. Okay, this has a 6 and a 5. Okay, what we're going to look to do is always attack the power that's the smaller one and change it. So this is going to go, because this has the smaller power of 10. We need the powers of 10 to be the same. So 5 is going to go up to 6. If this is going to go up, the 8 has to go down to become a 0.8. Just move the decimal 1 position. And now we can add these. The 10s to the 6s are the same. If 9 adds 0.8, the 9 is like a 9.0, if this helps you. Keep the decimal lined up. That'll get us a 9.8. If this had been a subtract, we'd go 9 minus 0.8, a little bit of borrowing there, and we'd have turned out an 8.2, but it would still be a 10 to the 6th. Same thing on this. There's no variety, it's just a reinforcement. Okay, when the powers are not the same, pick on the one that had the lower power. Always make the lower power go up 1 to be a match. And if the power is going to go up, this part of the number has to go down by getting a decimal point involved. It has a decimal at the end, just nudge it 1 position to be a 0.3. The 7 is like a 7.0. The 0.3 is like a 0.3. Line them up if you need to. If we're adding those, it's 7.3, and it would be 10 to the 5, because we're making sure those powers of 10 are all the same. If we were subtracting, you'd have to do a little bit of a borrow kind of thing, and we'd get 6.7 instead, but it would still be 10 to the 5th. Okay, so again, to summarize, when the powers are different, attack the lower one. The lower power will increase by 1 to make a match, and that match will be in the answer. When you make the power bigger, you pay for that by making the number smaller by just sliding the decimal left a position so it's before the number. As long as the powers are the same, add them up. Add the numbers up or subtract the numbers depending on the problem, but keep the powers of 10 all to be a match. When adding, be a little bit cautious. Every once in a while you'll add and your result will go over 10, and then that's going to need this balancing move, where the number will have to go down while the power goes up. It's the same move essentially we did over here, where the number went down while the power went up. See you next time.